Sharing the screen. Yes, perfect. All right, cool.
I think the link.
Okay.
Like
Then when it's your turn, I'll just call you. Okay. Cool. Should I stop the music here, Paloma, or? Oh. What's the volume? Sorry.
Okay.
Cool.
Sorry for the delay, everyone.
Yeah.
On time. Very good.
Well, yeah, I changed the times because we were late. Okay, so hi everyone. So the idea for this night is that we have a very long socializing period. Then we're gonna have this little introduction. Afterwards, Carlos is gonna tell you a little bit about the governance side and like the structure of Project Jupyter. Then I'm gonna talk a little bit about Jupyter internals, and then yeah, at 10 p.m. is the end of the event. So today we're gonna have these 4 people. We're gonna have Ana Paula, that's not here yet. She's gonna be here a little bit later. She says she's a crazy open source lady, city hacker and software engineer at Metro. Yeah, we're also gonna have Carlos, that's by my left side. He's working as a scientific software developer at QuantStack, which is a very important company in the Jupyter ecosystem. They do a lot of stuff. And he spends a lot of his time improving Jupyter ecosystem. Me, my name is Mariana. I worked at QuantStack also, and I'm a Jupyter Distinguished Contributor. I'm a member of the Jupyter Widgets and the Non-Focus Disk Committee. And we have Paloma, which is an open source advocate, and the software engineer and the DevRel, and also our host. So if you need any stuff about like the events, then you can talk to her. Okay, so this event is hosted by PyLadies. PyLadies is a group organized mainly by women, but not only by women, right, Paloma?
But now we have Cristiano.
Yeah, we have Cristiano. Yeah, sorry, I never done this part of this introduction, but our group is distributed around the world, and our intent is to empower women and other minorities inside of tech, because I'm not sure if you realize, but there's a disparity of like women inside tech and like all kinds of diversity inside tech. So the point of PyLadies is not one of creating separation between people that are minority and non-minorities. Is just a place for people that are minorities to feel like secure and feel like that they have a place, and they can also contribute to the Python ecosystem. Okay, so this is exactly what I said. Our code of conduct is basically, don't harass other people, be nice, don't assume that people know things. I think that's very important. Maybe you're very, very expert in one thing, but then you don't know anything about this other thing, and that's all right. And to assume that people don't know something and like mock them about it, that's really disrespectful, not cool. Just like be nice. Okay. The good thing about PyLadies is that it's a completely open and very horizontal community. So we're just a bunch of people who really like Python, really like open source, and want to do cool Python things together. And you can join us. You can join us in many different ways. If you think you have like some kind of interesting thing to talk about Python, you can offer to give a talk or workshop like this. You can also join our group and help us organize meetups. And that's really cool because when you join PyLadies, a bunch of conferences in Europe give spaces for PyLadies, both for PyLadies talk, but also like we always have a booth, for example, in PyCon.de. So it's a good opportunity for you to get like free tickets and just go and interact with the Python community, and you have a booth. So you have a reason to be there. So people come up to you and talk to you, and you can come up to people and, talk to them. You have like a good reason to start a conversation if you're shy like me. you know, and you don't know how to start conversations, you can just say, oh, I'm a PyLady. So what are you doing here? Can we like do something together? You can also join as a coach to one of our workshops. That's what Ana Paula is doing. Yeah. And how do you do that? We have a Slack. So it's that thing, slacking.pyladies.com. You can also just look for PyLadies Berlin in the internet, and we have a website where these links are there. And yeah, or just like write us an email, anything. We're reachable online. Okay, that was the last slide. So I think now I'll hand over to
Can you open the issue there?
Carlos. Sure. PyLadies Berlin. It didn't work though.
No. Because it's already saying.
What?
No.
But it's not over there, you know what I mean?
Yeah.
Oh, because because Paloma only shared this one thing here, this one tab.
Stop sharing
Uh-huh.
and share the other.
Yeah, you want to do this? Oh man.
Paloma, how do we share the?
Oh man. I'm ruining everything.
Yeah. No,
How can I share this tab?
Oh, and then you say share my screen and that password. Is this one?
Yeah.
Sorry, I have to share also with
Cool.
those humans of the internet.
So, hi everyone, I'm Carlos, as Mariana already introduced me. I'm gonna do an overview of the project Jupyter. What's the current governance, how it's organized and managed, and a small overview of the different projects, because right now the project Jupyter grew a lot and is huge. It's really difficult for a beginner to understand every part of the stack. So yeah. The project Jupyter is an open governance project with who is in charge of managing well-specified standards. These are the messaging protocol for kernels and the notebook format. Apart from the standards, there is multiple libraries that we can reuse in different parts of the stack, but not only us, also some of the companies that are implementing their own applications around the standards, like Databricks or Google with Google Colab. They all implement their own applications for these standards, but we encourage them to reuse also some of these libraries. At the same time, we have user-facing applications that will be Jupyter Notebooks, JupyterLab, Voila, etc. And it's all an open ecosystem. Well, this year we changed the organization of the project. Basically, now we have an executive council, which is the ultimate responsible for all the decision making in the project. But behind the executive council, we have also the software steering council. The reason is there is a lot of projects. You can see on software subprojects, we have accessibility, foundations, kernels, notebooks, security, server. All of that is different subprojects inside of Jupyter. It's really difficult to have one person of a group of people managing all the projects at the same time. So we needed to change the organization to have more flexibility. That's why now we have different subprojects where there is multiple collaborators in there, and each of the projects elects one of the members as a software steering council representative. And that software steering council is the group in charge of taking the decisions that concern multiple projects at the same time. For example, if we need to change something on the notebook format that involves the Jupyter server, the JupyterLab, Jupyter Notebook, so we cannot take the decision from, for example, where I'm most involved in JupyterLab. We need to include all the other groups. That's the responsibility of the software steering council. Apart from that, we have other groups that are not technical. Not all the collaborators are developers. There is also people that's in charge of managing the code of conduct, diversity, inclusion, operations, legal, fundraising, events, community, etc. Those are the standard committees, which they also have a representative in the software steering council to be able to vote for the executive council and some other decisions inside of the project. And then we have also working groups, which is kind of a smaller groups that can be created for example, organizing a specific event like JupyterCon or things like that. Now let's look at the project and what are the different subprojects that we have inside. First of all, something that's new, it didn't come out yet, is the new version of the notebook. Don't look for the difference, it's the same picture. The idea is, right now, the classic notebook, the notebook that you probably know, all of you, when you do pip install notebook, is the left image, let's say. It's the technologies that we used for implementing it under the hood is too old. And we needed to update it and move from using jQuery to use other technologies, modern, and that are up to date. So what we decided is we created the new Notebook 7. The idea is that it looks the same. In a couple of weeks or maybe in a month, 2 months, don't know yet, we will release the new version of the Notebook 7. The idea is that once you do pip install notebook, for you it will be the same. The problem will be that none of the extensions will work at the beginning. The idea is we are working already on updating all the extensions, so people doesn't have to wait for all those extensions to come out. But yeah, in a couple of months, if suddenly you install the notebook and you use some specific extension and they don't work, please check if the version of that package is the version 7, because you can always go back for a few months until we update all the extensions. Now, apart of the notebook is the first, let's say, version that we implemented. It's the single page document, but apart, we also have JupyterLab. The idea of JupyterLab, it was created 4 or 5 years ago. The idea was to replace the notebook. It was the notebook, the technologies that we were using behind were getting too old. Some of the libraries that we use in the notebook, they are not maintained anymore. So we needed to update it. We created JupyterLab, but people didn't change. People prefer the notebook, and even today, I believe the notebook has more users than JupyterLab. That's why this year we decided to create the new Notebook 7 using components from JupyterLab. The difference is the notebook is a single page document where you can launch it and you focus on one notebook, one document. In JupyterLab, the idea was to create a web-based IDE. where you can open multiple documents at the same time. You can open a console, also the terminal, have a file browser, like an IDE. And yeah, one of the best parts of JupyterLab, and that was one of the key features for its architecture, is that it's completely flexible and extendable. Everything is an extension. That's why we could create the new Notebook 7 and some other applications that we built on top of it. Regarding kernels and widgets, I'm not going to enter into details. Kernels basically provide the computation and the communication with the front ends. The front end will be JupyterLab, the Jupyter Notebook, or for example, the IDE Spider or the Qt console. And the kernels are the different kernels that are available for different languages like Python, Julia, and basically there is a standardized communication messaging protocol that we use, so every front end can communicate with every kernel. Mariana will talk more about that later. On the other side, we also have the widgets, which allow, probably most of you already know the widgets, but they allow to visualize that data and interact with the data. Not only just visualize it, but also be able to change some of the parameters, so we can quickly prototype some workflows where people can interact and explore that data. Finally, there is more subprojects that I'm not talking about, but these are the main ones. And the last part of the stack will be Voila dashboard. Basically, Voila converts a notebook into a standalone app or into a dashboard. So the idea of Voila is not everyone looking at a notebook, it's a developer. So maybe you as a developer create a notebook to do some exploration in some data. And once it's done, you want to show to your managers, to someone that's not technical. So you can use Voila. Voila basically turns the notebook into a dashboard, removing the code and showing only the outputs. And the last, the newest project, basically JupyterLab is not an application by itself. Basically, JupyterLab converts JupyterLab or Jupyter Notebook into a static web page, something that you can deploy in a static server where everything runs in the browser. What it does is, instead of using the normal kernels to, for example, have the interface of JupyterLab in your laptop, but you're connected to a remote server in JupyterLab, sorry, everything runs in your browser. We compile some of the kernels into WebAssembly. So when you execute the different Python code, everything that you're writing in the notebook, instead of making the request to a remote server, it will run in your browser. The idea is, for smaller applications or showcases, or even for education, having a deployment for, let's say, a classroom with 1,000 students, it requires a lot of computation. The idea of JupyterLab is to just reduce the amount of computation that we need. So instead of running it in the server, we are running it in the user browser, and it removes all the configuration. You no longer need to install, create your environment, install all the dependencies. Like the manager of the organization can do that for you, deploy it, and the user just enters to a website and everything is there. You don't need to configure anything. That's the idea of JupyterLab. And that's all. Let's move to Mariana. We will show this later. This is the different parts of the stack where you can collaborate. I'm not sure what's the level of everyone or what everyone wants to get involved in. There is a lot in the Jupyter project. You can choose. Maybe some of you, if you are data science, instead of just fixing some of the issues that we have, good first issues, or even more complicated if you want, you would prefer to create your own widget. Maybe if some of you are data science and you use the notebook as your daily ID, one cool part of Jupyter is that you can create your own extensions, you can create your own widgets, so you can improve your workflow and automatize all those tasks that you do every day by just creating an extension that does it for you. So maybe you might be interested in that. Maybe you want to creating your own extension. It's also a part of collaborating into the Jupyter project because you are increasing the ecosystem and it's easier to find bugs on the different tools that you will use to create your widgets and anything you want to create. And then you can report those bugs upstream and fix them upstream, and you will also be contributing. If you don't know what to work or what to do, we have some issues already that are prepared for people that never contribute to JupyterLab or Jupyter Widgets, Zeus kernels, Jupyter Server, anything. And you can also tackle those ones. We will show this slide at the end, and you can also choose. And now let's continue with Mariana.
Shall I share it in the meeting page or something?
Yeah, I sent you on Slack.
Okay. The last one?
I don't know. Yes. Share this tab instead. You don't need to do everything. Oh, again.
Sorry.
Okay. Thanks, Paul. You're welcome. Thank you. Forward. So the idea of this this slide deck is to give you an overview on how Jupyter works, both on the server side and also on the front-end side. Because when I started to develop widgets in Jupyter, I was just copy-pasting code. And I think it's useful to at least have like a high-level overview of the concepts. And I almost don't talk about code. It's mostly like literally how the code is organized and how it works on a higher level. So to make sure that everyone is in the same page, I listened to a little bit of you talking. Some people seem quite experienced. I'm not sure about the rest, but it's not a problem. So first I was gonna make a distinction between notebooks and lab because a lot of people I talked to like didn't even know they were a different thing because I think everyone's using notebooks. I'm not sure, but Carlos did a great job on that, so I'm not getting into that. But something I'm getting into in these slides is the difference between the server and the interface. So if you ever open JupyterLab or Jupyter Notebook in your terminal, if you ran like JupyterLab or Jupyter Notebooks, you notice that there's a wall of text that starts going in your terminal, and then it prompts you to your browser. So that's the server. The server is the wall of text in your terminal, and the interface is whatever is happening in the browser. So yeah, we're gonna talk in details about that, but for this workshop, I'm bringing my knowledge in the Zeus kernel stack and also in the widgets expanded universe stack. So yeah, we're gonna talk more about it in the future, so I'm not gonna get too much into it, just some outline that we're gonna learn about these things. The Zeus stack is related to the server side, and the widgets is related to the interface side, but they also have a back-end component that also runs on the server. We're gonna talk about environments, not in this talk, but we're gonna help you with environments because there, as Carlos showed, there's so many different projects that was not possible to just say, oh, come prepared, install this in your machine. So we're gonna have to deal with environments here. Conda or Mamba is recommended, but we can make it work with other stuff too, I'm pretty sure. Another thing I'd like to say is if you have trouble navigating with Git, maybe you're not used to using Git, it's not a problem, just ask us questions. It's, Git, you can get into some pretty nightmare situations with it. So yeah, it's not a problem. So does anyone have any question now? If you have any questions at any point, just interrupt me and ask. Okay, let's get into it. So Jupyter can be divided in these three main blocks. It has a kernel, a web server, and a front end. So what is a kernel? Maybe you've heard this word before, but you have no idea what it is. Well, it's because maybe it's a very broad concept. A kernel is generally a very important part of the software that's like very central to it, and that's why it's called kernel. So in the JupyterLab, because we're only going to talk about JupyterLab here, in JupyterLab, when you install JupyterLab out of like pip or conda or mamba, what you get in your computer is the IPython kernel. So if you go right now, if you have JupyterLab installed in your computer and you go right now on your terminal and you type IPython, you're gonna open an interface that's just like a notebook interface, but it's in your terminal. And it contains cells and it contains features like history and like writing many lines of code in one block of code. So if you're like me, like to write little snippets of Python code to understand what's happening in like the bigger picture or, just like weird stuff that there exists in the language. And you usually use Python in your terminal to do this kind of stuff. I really recommend using IPython because it's much better. The UI, the UX, not the UI, because there's not really a UI, but the UX of using it's much better. So, all right. So that's what Jupyter has out of the box for you. That's the kernel out of the box, IPython. And then the web server is something that's running on your computer to make Jupyter work on your browser. And then the front end is the, all the buttons, the pretty interface, the stuff that you click, the front end. So the way JupyterLab works is it interacts with these different parts of it using these little connections you're seeing. Like, so between the kernel and the web server, there's this library called ZMQ, which is a low-level message passage library protocol, and it's like super annoying to use. It's like very, very difficult in my opinion. And similarly, we have the WebSockets for to make the connection between the web server and the front end. So that's how information from the kernel, from the computations you're adding to the kernel, you're making on the kernel, arrive to the front end. And that's how the information you're interacting with in the front end arrive back into the kernel through these libraries that make this message exchange. The thing is, they're really complicated and it's really annoying to do it. But the good news is that Jupyter people came up with an API. They use these comms, which is an API that like just abstract all of these message passaging protocols and like weird stuff. And it's much easier to use. So that made JupyterLab much easier to interact and like to expand, etc. Okay, so that's the comms interface. So I'm going to talk a little bit about how code is executed. So as I was explaining, JupyterLab has these three parts, but here we're only seeing two, the kernel and the front end, because they're mainly the most important ones. So the kernel is literally the part that makes the computations, and the front end is literally the parts that like show you the pretty stuff. So if you're doing something like 2 + 2, you're gonna type 2 + 2 on the cell 1, you know, the cell of your notebook. Your notebook has many cells. I'm not sure if everyone is aware of the format of the notebook, but yeah, notebook is composed of many different cells, and each cell is a complete little thing where you can execute the code and receive a response. So notebook is composed of these. So in the cell, you type something like 2 + 2, and then you expect a result. That's 4. But the part of the code that's making this computation 2 + 2 is not your browser. It is the kernel. It is the IPy kernel, which is the, you know, the Python implementation that actually takes that string, those numbers, 2 + 2, and computes and understands, oh, okay, this is a expression, a mathematical expression, computes it inside the kernel, and then sends it back to the notebook. And the way they do this is by message passing and using unique IDs. So, oh, well, yeah. Here I'm more specific about it. So the way it works exactly is you execute an event in a cell, and then this message is generated with a unique ID, and it's passed through the front end to the kernel. The kernel receives this message and is like, all right, 2 + 2, I will do it, but don't talk to me, I'm busy now. So now it's going to send a message back to the front end, back to the cell, which is, if you ever done like expensive computations inside JupyterLab, you see that there's a spinning thing. And that's, this spinning thing is triggered by this message. So the kernel is busy, so don't do anything else. And once the kernel is finished, I forgot what's the message name. I had it in my notes, but it's gone because I can't see my notes. Well, once the kernel is finished, it sends an execution finish message with the actual result back to the notebook. Okay, so this is the general overview on how like Jupyter is doing things. Now I'm gonna get like computing things and showing things on the notebook. Now I'm gonna get into something that's widgets, and Carlos already explained a little bit about it. So when you do 2 + 2, that's just, you know, a string of a computation and you just get the result 4. But the cool thing about JupyterLab is that it allows you to interact with your data. And the way it does it is through Jupyter Widgets. So this is just an example of the IPyWidgets library. The IPyWidgets library comes with the IPy kernel, and you can do all kinds of stuff. Let me see. Yeah, you can create, for example, slides to interact with your data. You can create radio buttons or buttons, you know, all kinds of stuff. And the other thing about the Jupyter ecosystem that Kyle's already talked about is that way cooler than that is that you can create your own widgets. So the way, one thing I forgot to mention is that the kernel is, the way you interface with the kernel is in Python, and the way you interface with the front end is in TypeScript. Ideally, but you can also write JavaScript. At least you could. I'm not sure if you can see, yeah. That allows you to do all kinds of cool things. So this thing that we're seeing, for example, is a library that's a JavaScript library. And to add it inside JupyterLab, it wasn't so hard at all. Like there's a cookie cutter that allows you to that writes a bunch of the boiler code for you. So you can somehow easily transfer JavaScript libraries to JupyterLab because of this interface with the TypeScript. And then you basically only have to write like the Python side that's gonna interact with the server. yeah, so this example is an example of a widget that I'll be mentoring today in case you want to join. Currently, the widget's not working, but Carlos guaranteed to me that it will work soon.
It's not guaranteed. I
Maybe
think
not.
it's maybe because JupyterLab
Yeah.
released it last week and everything is broken right now.
Yeah, everything that's using Jupyter Lab for like what I think, because I didn't pin the version, I think that's why it broke, but yeah, let's see. So yeah, another thing I'd like to talk about that's I don't know if it's so relevant, but it's part of the Jupyter internals implementation, is that every single state of every single widget is synchronized inside JupyterLab. So here you have a widget model that's on the server side, or like the representation of a widget in the kernel. And on the right, you have a widget model that's the representation of a widget in the front-end side. And then these two widgets, remember earlier I talked about how this generates a unique message for the execute message to send it back to the kernel. These two widgets are gonna have the same unique ID for these two messages. So these two messages are gonna be synchronized all the time. So what does that mean? Well, if you're interacting with a widget through the server side, which would be like, you know, you have a variable that's attached to a slider, and then you say x, which is the variable, equals 5. Then your slider suddenly jumps to the number 5. Then you interacted with this widget through the server side, but you got an update on the front-end side because of the synchronized state. So everything in Jupyter is synchronized, and the same way, the other way around, if you're like on the JavaScript side and you click on the slider and you change it, the value was 5, now it's 50, and you try to print your x variable will be evaluated to 50, then you did the same thing, but on the opposite side. Hopefully it's not too confusing. Okay, so this is talking about how to spawn a new widget. So the way it works is a widget is created on the server side, a com message is generated, this com message goes to the front end, go to the com manager, and the com manager constructs a new com message in the front end side that's going to be attached to this the backend com. And the com manager will also call the widget manager, which is a class. I'm not sure if you have to implement it as a boilerplate or if it's already in the libraries, but it calls the widget manager, which is the class that's responsible for spawning new widgets. And the com manager is going to give all the information, all the metadata that's that came from your backend, or in this case from your Python side. We'll give all this information to the widget manager, and the widget manager will be able to create a widget model or a graphical representation of your server-side objects. Yeah, and that's how a new object spawn. Yeah, with a widget. Widget view is another. It's another class that's called. Okay, so the widget model creates the metadata in the front end side, and the widget view creates the actual view of the widget. And I think all of this is implemented for you as a boilerplate, but I'm not completely sure. I think
What part?
the widget view and the widget model is like, it's something you don't really have to worry so much about, because I think it's the cookie cutter and you have to modify it, but I'm not entirely sure.
I mean, there is a small example on the cookie cutter when you run the template and create the extension for you, or the widget for you in this case. There is a small example, I believe. But you have to complete it.
Yeah. Yeah, so if you're contributing to widgets, this is the kind of structure you will see. You will see a class, not sure if the widget manager is there, but you will see a class for the widget view and a class for the widget model. And
The widget manager, it depends on the application that you are using. For example, we have one widget manager for the notebook. So anytime you install a widget on the classic notebook, automatically, so if your widget depends on IPyWidget, which it should, IPyWidgets depends on the widget manager when it's installing. And it install, the widget manager is part of IPyWidget.
Oh, okay.
It install that part in the front end in the application.
So you don't really have to worry about, you just inherited. Yeah.
And then we have another widget manager for JupyterLab, because both technologies are different. For example, Google Colab also supports widgets. They have their own implementation of the widget manager to support those the IPyWidgets and some other custom widgets. So that part is on the application.
I see. Yeah, so in general, it's something you won't have to worry about. Okay. So this was a small introduction on widgets, and I would like to talk a little bit about Zeus to see if anyone is interested in this. So Zeus is a framework that's used to make it easy to implement new kernels for Jupyter. So I just explained about IPython, which is the kernel that comes with Jupyter, but there's a whole universe of different kernels you can use to attach to JupyterLab. So for example, here we're seeing this example of an SQL kernel. So as you can see, I'm not sure if it's too small, but as you can see, instead of writing Python in this Jupyter notebook, I'm actually writing SQL. I'm loading a database and like writing SQL code. And someone was saying earlier that that they miss the debugger inside Zeus, and that's why they're using the PyCharm solution. But Zeus also offers a Python implementation. It's called Zeus Python, and you have to install this kernel in your JupyterLab, and it offers you a debugger. So you can just debug your Jupyter notebook. So you can do all kinds of stuff with Zeus, and there are implementations for SQL and all kinds of like SQL flavors, SQLite, Firebird, I think Postgres, no, but a bunch of different SQL flavors. There's Lua, there's a bunch of languages. Yeah, sure.
So the first kernel that was created was IPyKernel. It's the default Python kernel. It was built on top of IPython. IPython is an interactive console for Python. The idea of IPython, to start from the beginning, is when so IPython implements the how was it called? It's a REPL, like the read, evaluate, print loop. So a small program that you can write some code, it's executed, and then it prints some output. So you can interact. For example, when you execute Python in your terminal, it opens the default Python console. That's IPython. The difference with the default one is that they abstracted the print, the read and print steps from the evaluation. So it's separated in two different processes, or even it can be separated into running into different machines. That's why we have remote execution. The read, or when you are typing, each on one machine in the front end, the evaluation each on another machine or in the same machine, but in the backend, and then the print is sent back to the front end and showed in the front end. IPyKernel, so IPyKernel came from, everything was started with Python, and there was other communities, I think it was Julia, that wanted the same, wanted to be able to remote execute and have notebooks for Julia. So they decided to extract it from all the implementation, all the communication. They decided to extract it from Python, and they could reuse it on other languages. What happens? To create your own kernel for another language, SQL, C++, Lua, Haskell, whatever language, there is different ways. One is you can reuse the communication mechanism from IPyKernel, or you can use Zeus. Zeus is a library that implements the communication. All the
Yeah, I'm gonna talk about this part a little bit next.
And basically, Zeus, you can use it on any language that has C or C++ bindings. For example, Python has C bindings. Zeus is written in C++, I believe. So you can write a small program, let's say, that's just the different communication parts. For example, when you need completion, when you are writing code, have some auto-completion, you write a small function that returns that to the front end. When you want to check your code, you write a small function. Zeus offers a small class that you just need to complete those functions for the specific language you want to use. Since it's written in C++, if the language you want to use has C++ or C bindings, it's very easy. And it's recommendable to use Zeus instead of IPyKernel mechanism. And that's all.
Yeah, so as Carlos was saying a little bit about, so this is how Zeus works in a higher level. So in this example, we're seeing over there on the upper corner, upper left corner, the Zeus Lights kernel. That's something you can ignore. I should have erased that, but I forgot. But this image is actually explaining how JupyterLite works. And JupyterLite is using PyLadies as a kernel. So it's a little bit different. But the main part we want to pay attention is the main box written Zeus. So Zeus has three main blocks: the server, the interpreter, and the debugger, which are gonna communicate with, and all of them are talking to this kernel core, which is, as Carlos was saying, is any language that has bindings for C or C++. So that's why we have an SQL kernel, a C++ kernel, a Python kernel, and a few others, because all of them can be called within C++ and they're already like implemented. So it's really easy. You just, all of this server, interpreter, debugger, this lower part depends on this main library that you're using. And all you have to do to implement these parts is implement not a lot of code, because if you think about it, you're adding a whole new different language to to the the JupyterLab interface, and then you can make use of everything that the JupyterLab interface has. So if you look at this example, for example, here, this kernel is making use of the MIME types and generating all of these graphs. All of these graphs, you don't have this in SQL, right? This is not part of the SQL language. This is something called MIME types that's built in JupyterLab, and it's using Vega Lite to generate graphs. So you just get this stuff for free. Everything that's integrated with JupyterLab is free, is integrated for free. So this is the little bit of code I'm going to show, just in case people are interested in contributing to Zeus. Everything C++. This is a very ugly code. Like, don't, C++, it's ugly. But this is the boiler code. This is the part you don't care about. This is just like calling libraries and initiating the interpreter class, which is the main class you need to implement if you wanna write a new kernel. And these methods are the methods that you actually need to implement. So here we have the execute request, the complete request, inspect request, is complete request, kernel info request, shutdown request. So if you remember, whoops, I got a little bit into it when we were talking about the different messages you receive when the kernel is like generating a result, the result of a computation. So you have execute messages and busy messages, and these methods are just the way you have to generate these messages in an understandable way, to generate these call messages, which are gonna like do this whole thing of like synchronizing and doing everything for you. Like all you have to do is implement these functions. The most important functions here is the one in line 3, execute request implementation, which is the function that receives the string of code. You can see const std string ampersand code. So that receives the code from the user, whatever the user is typing. And then inside this function, you're gonna get this code and you're gonna call like the library that you're using that has bindings for the language that you wanna use to process this string of code and then give you the result. So in the SQL code, for example, is really, really simple. You just get the code. So the code is literally a string of text, right? It's like select all from table. And from, I don't know how to write SQL. It's not like that, but it's something like that. And then everything you have to do, all you have to do is to call the SQL interface and run this string of code. So it's like, it's very, very simple. And there are a few other things you have to do, but most of it is writing boilerplate code and like just completing the different names of variables you have. So that's a little bit how to create a new kernel for Jupyter. Yeah, and now these are frequently asked questions, but this is the first time I'm doing this, so I actually don't have any frequently asked questions. But I thought on one, which is, I wanted to say that widgets are attached to kernels. So, you have IPyKernel for, as the default implementation, and you have IPyWidgets. But if I'm, for example, if I'm running a C++ kernel, which now I can, just type C++ on my Jupyter notebook, IPyWidgets will stop working because the backend is all like expecting Python code and, all the Python interaction stuff. So like, it just stops working. But thankfully, there is an implementation of IPyWidgets to C++ that I forgot the name. Yeah. And here in these slides, you're going to find the links for the Zeus docs, a link for all the different kernels in case you're like interested in one specific language that's implemented by Zeus, you can go there. The Zeus SQL one, which is the one that I implemented and I know more about in case you want to help. It's really cool. People from universities use it, but I haven't been having the time to, it's just an open source and upkeep the project. So if you're interested, you can be like a maintainer, which is really cool. And you're going to help people in universities. They use it in classes and stuff. So that might be cool. I don't know. These are the useful docs for people who are gonna who want to like tackle widgets, because you have the widgets docs, which are like just like, oh, how can I use a slider? How can I, do observer or something like that? But the docs for developers are the ones like how to build your own widget. So there's the link there because it's always very hard to find this link, so I put it there. And and the widget that I'm bringing today is IPython because I also developed this one, but currently, unfortunately, it's not working. But this will be my project here, make it work. And if you want, we can pair up and check what's wrong. And okay, and this is also a link for the list of good first issues on IPyWidgets that I can help you with if you want to do stuff on the standard core library. And okay, if anyone has any questions. Yes, somehow, I'm not sure how, Paloma. Yeah. Yeah. Oh yeah, another thing I really forgot to say, and I should have said in the beginning, but I really forgot, is that I may be wrong at any point of this presentation, and I may have misunderstood something, and I'm explaining something wrong to you. So if you think I'm saying something wrong, please interrupt me. But I forgot to say that in the beginning. But yeah. Yeah. Do you have anything extra?
You can put my slide again. Anyway, are you all Python developers? Is it's all data science or Python related? Is there any front-end developer or someone that wants to look into front-end things? What would you prefer to work on? If you are a Python developer, Python related is IPyWidgets.
Sorry. But it was necessary, otherwise we would leave. Sorry.
So all the projects except for Jupyter Server, and kernels, they all mix JavaScript and Python. Anyway, the amount of JavaScript or the knowledge that you need about JavaScript is basic to create your own widget or even to tackle some of the good first issues in IPyWidgets. For implementing an extension for JupyterLab or Jupyter Notebook, then it's mostly JavaScript or TypeScript. So if you are Python developer, maybe create your own widget. To open source project. The idea of those good first issues is that they are very well documented. Even in some cases, they explain how to fix the issue. So they are meant for encouraging people to contribute and to get into the project. So now you have to choose what project you want to contribute.
How do you choose it? Like, what are the options?
Yeah, so the end of my slides, all of those links are options, for example. I don't know where.
Can you send this link to the chat?
But you want to show them maybe because it's heading you to development.
For example, in this link over here.
But the thing about good first issues is that there are all kinds of issues. There, if you don't want to code, there are like documentation issues. But yeah, there are issues that gonna take you like maybe 15 minutes, but there are issues that are good first issues, but might take you like an hour or more. So
to find the good first issues, you can go to, for example, the repository IPyWidgets, and then in issues, you can select label, this one, good first issue. And
Yeah,
then
you
you will
just
have
place
here a list of different issues that you can work on. There is 38. I think we have enough in IPyWidgets.
Yeah.
But most of them have like, I was thinking of, and most of them have conversation already, I don't know, like, what is still.
So, for example, this one, Padimul and Martin.
Yeah, they were talking
So-
about doing it, but they didn't do it.
Exactly. Martin is one of the main contributors, so I'm sure he is not taking this issue.
Yeah.
So
But shall we like write in the comments, like I'm taking or?
Yeah.
it's not really necessary. You can do it.
No, I think you should do it.
No, exactly. What I would recommend is to say it here. One of the problems that we have been having in JupyterLab, for example, so I'm focused mostly in JupyterLab. I don't work on widgets or kernels. And one of the problems that we had in JupyterLab is that there is a lot of people that tax themselves as they want to work on that issue, and then they never come back. And then when someone wants to go and work on that issue, they see that there is someone already tagged to work on that issue. So they say, okay, maybe someone else is working, so I'm not going to work on it. That's why right now we prefer if people doesn't say anything unless they are sure that they are going to work on that issue, they are going to have time, and they are going to do it, fix it.
Hi, everybody. My name is Anna. I'm gonna talk something here today. I never contributed to Jupyter or any of the related projects myself, but I have some experience with all these projects. And then one thing related to this is like always take a look at the contributing guide from each project. For instance, in the Jupyter project contributing page, they are saying that you should comment on the issue and open a request just saying that you are committed to it. So I know the others maybe don't have this. I always find it a really good practice. But yeah, it would be nice if we could avoid just going there and then just leave it, because other people maybe will try to contribute to a project and then we see how someone else is working on this and it's going to be like laid there forever.
This just made me like it may not be will be my first time doing it. One thing that I don't know if I actually am able to see that. And if I put my name in there and I do the full, I do the full, I create a branch and stuff, and I cannot do it. But I mean, what works for me, I mean, that's going to be share it, but just what works for me is that I go to an issue and then I read it, I read the comments, I try to play around with the code to see if I can remember to stay over on the machine. If I can do it, if I have an idea on how at least to search information related to it or what it's about, I go for it. Otherwise, I just go on to the next issue because it's really important that you understand at least a bit of what it's about. Because one good thing, especially when it comes to your first contribution, is just like try to do something that you feel like you can do it, you feel like you can understand it. Otherwise, it's really frustrating and you're gonna just give up at some.
No, that's why I was saying that maybe don't write from the beginning, because for example, I'm quite shy, so I would prefer to not say anything in case I'm not able to fix it. I will, what she said, experiment, make sure that I can fix it, and then if I don't have time to fix it now, I will say, hey, I will work on this and I'll fix it tomorrow, So yeah, what I would suggest is let's talk here, say here who wants to work on what issue, And then once you looked into the issue and you started coding and fixing it, you can already comment on the issue and say, hey, I'm gonna work on this. We'll open up here, etc. So yeah.
So first, watch out with the eyes. I'm turning the light again.
Mhm.
I'm sharing now the presentation so you can get into the different repositories and you can speak it out loud or ask for the Carlos, Mariana or Anna's help for some stuff specific, for some simple stuff you can ask me. But I'm also trying to help people online and you as well. And you can just say, hey, I'm taking this. Maybe you can pair if that's your first time. A super good practice. Just sit down with someone with a little bit more experience than you. Follow along, that's super helpful too. But those slides are for. This can be tricky and hey for you. It's gonna be super fun too.
Oh, do we have
Gonna put music on?
do we have stuff to write on
Yep.
this? We do.
Maybe we could write which projects we were working on and maybe on there. Or like which. Yeah, another thing I'd like to add was everyone I ever met in the Jupyter ecosystem was very, very sweet. It's like the sweetest ecosystem I ever was a part of. And I think people are really like, you know, if you say like, oh, this is my first issue, the first time I'm contributing here, people are gonna be very, very welcoming.
Sharing.